So you take a coin, you don't have a coin, but I saw this rubber over here. Now, if I throw this at it with a particular force, in principle, I can say what will happen to it. In principle, I can solve Newton's laws of motion for this. And I can predict whether it will come with Kitco or blank. Now, maybe I can do this, but I will need a supercomputer because it is quite complicated. Because, first of all, the amount of force that was exerted on it and the place at which it was exerted, all that has to be put into a calculation. And then I have to put in air resistance and the temperature of the room and everything, so many different, the properties of this rubber and so forth. So in principle it can be done, but in practice it is very difficult. But it may, बिल्कुल इनिशियल, तो मैं ये कह रहा हूँ कि अगर इनिशियल कंडीशंस एग्जैक्टली नोन हो कि मैंने कितनी जोर से इसको ऊपर उछाला और किस जगह से और सब कुछ, फिर भी कामयाबी के इम्कानात बहुत कम। वजह ये किसी को छींक आ गई, छींक से अतराफ की हवा चलने लगी, जिससे बहुत ही सेंसिटिव है। So it is very difficult to predict, and so instead what I will do is I will do a little experiment on this. I will throw this 500 times and see how many times it lands with this and how many times it lands with this. Okay, maybe 500 is not enough. Maybe I will do this 5 million times or 5 billion times. And if I find that half the time it comes with this and half the time with this, then there is, I say, a probability of 0.5 that it lands on this side or on this side. So, this is how we will determine the outcome of this. We don't know whether it will land up or down, but with 50% chance this way, 50% chance that way. Now, even if we could, suppose we could predict this, but now take a gas. In a gas you have got 10 to the power 23 molecules. Suppose I used Newton's law of motion to calculate what each one of these atoms is doing, where it is, how fast it is moving. In principle, I would get, in principle, I could predict the motions of all of those atoms and molecules. But in practice, again, this will be impossible because even the smallest perturbation on this will completely change my calculation. So therefore, it is not useful for me to try and do this problem exactly. It is much more useful to use the idea of averages of probability. So that is why we need this in classical mechanics. Classical mechanics, at least I have Newton's laws, which I can solve. But in quantum mechanics, even that is impossible because you cannot say where an electron is at a given time and how fast it is moving. So there you always have to use the concept of probability. So it's So I could say it is convenient for classical mechanics. It is necessary for quantum mechanics. हाँ,
ये पूछना था मैंने कि प्रोबेबिलिटी अगर फर्ज करें एक काइंड की बात करें तो हाफ ऑफ प्रोबेबिलिटी हेड या टेल, लेकिन एक्सपेरिमेंटली शायद इसे वेरीफाई करना बहुत मुश्किल होगा, क्योंकि फ़र्ज़ करें कि 10 दफ़ा मैंने कॉइन फ्लिप किया है तो प्रोबेबिलिटी के सूझे कहते हैं कि हो सकता है कि तकरीबन 5 दफ़ा, 4 दफ़ा भी हो सकता है, 6 दफ़ा भी हो सकता है हैंड आए, ठीक है। तो 20 दफ़ा करूँगा, 12 दफ़ा भी हो सकता है, 8 दफ़ा भी हो सकता है, 9 दफ़ा भी हो सकता है। तो यानी कि उस पॉइंट के इर्द गिर्द हमारी एक्सपेक्टेड वैल्यू घूमेगी। लेकिन हम ये कैसे एक्सपेरिमेंटली श्योर हो सकते हैं कि एग्जैक्टली दिस इज द पॉइंट?
तो उसमें फिर ये है कि आपको नंबर ऑफ एक्सपेरिमेंट्स
जितना मर्जी सैंपल रिलीज करें वो फ्लक्चुएशन रहेगी।
आप उसको अप्रोच कर सकते हैं। आप ये कह सकते हैं कि द प्रोबेबिलिटी इज द नंबर ऑफ ट्रायल्स, द डिविएंस, वो फिर हम बात करेंगे व्हाट इज डिविएंस, बट if you are approaching half, then that will be the asymptotic limit. But to say that, okay, in the case of a coin, a physical coin, you cannot ever prove that the probability is exactly half, because you would need an infinite number of trials. So then you will have to define an ideal coin. Ideal coin, maybe no such ideal coin exists. वो जो टॉस में इस्तेमाल होता है क्रिकेट में, तो हम फर्ज करते हैं कि आइडियल कॉइन, लेकिन किसी ने उसको बार बार करके नहीं देखा कि एग्जैक्टली प्रोबेबिलिटी उसकी हाफ है कि नहीं। अच्छा, बहुत बड़े बड़े बदमाश होते हैं जो कॉइन्स नहीं, 500 डाइस को लोड करते हैं। these are called loaded dice. एक आम डाइस में जो आइडियल डाइस है उसमें 1/6 प्रोबेबिलिटी है कि वो किसी भी एक पर है, लेकिन अब जैसे कैसीनो में होता है उधर ये चालाकी की जाती है, जो गैम्बलर्स होते हैं उन्होंने अपने डाइस रखे हुए होते हैं जिनकी प्रोबेबिलिटी ज्यादा होती है कि किसी एक तरफ गिरे। यू कैन डू दैट। हाउ कैन यू डू दैट? यू मेक वन साइड हेवियर, उसकी वेट डिस्ट्रीब्यूशन आप इस तरह से बनवाएं कि वो उस साइड पर जाके गिरे। तो ऐसे लगता है आपको कि 6 साइड बराबर की प्रोबेबिलिटी रखते हैं, लेकिन एक साइड में ज्यादा है, उससे बड़ी कमाई हो सकती है। Okay, so this is why it is there. Now the next thing I will define is a random variable. Here I takes values 1, 2 up till n. So a random variable would be, for example, you take a dice. The dice has got let's say 1, 7, 9 on this side, and on that side he's got 3 other numbers. 1, 2, 3, 4, 5, 6 लिखने की तो कोई जरूरत नहीं ना। Can be, you can put different numbers over here. So then the random variables will be x1 equals 1, x2 equals 7, x3 equals 9, x4 equals something, etc. यहाँ 6 होंगे, I equals 1 till 6. The probability of xi is denoted as Pi. And Pi has the property that this is equal. So this dice, whether it's got 1, 2, 3, 4, 5, 6 or 1, 7, 9, 11, 17, जब आप फेंकेंगे तो किसी ना किसी साइड पे तो गिरेगा, एक साइड ऊपर होगी जो भी. So all the probabilities must add up to 1. How do you define Pi? Well, Pi, we just talked about it. Pi is equal to the number of times xi occurs divided by the total number of tries of events. And we can't ever know probabilities exactly for a physical coin or for a physical dice, as we just discussed. So then we say that there is an ideal coin or an ideal dice. Ideal coin will have P1 equals P2 equals half, etc. With respect to xi and pi, we define averages. We define the average of xi as, and we give it the symbol x. So x is xi here. I goes from 1 up. So whatever random variable is, you weight it with its probability. If, let's say over here, let's say that x1 is 1, x2 is 7, x3 is 9, और जो तीन दूसरे faces हैं जो मैं दिखा नहीं सका यहाँ पे, x4, let's say that is -1, x4 is -7, and x6 is
-9.
Is 11. These are 6 random variables. Now let's say that this is an ideal dice, in which case all the are equal. Well, in that case, what will be the average value of x that we will get? In this case, for this example, we'll get 1 into 1/6 plus 7.
So 1/6 सब में से कॉमन आ जाएगा तो आपको ऐड करना
Okay, I don't want to write 1/6. Okay, so I will write 1 plus 7 plus 9 minus 1 minus 7 plus 11 into 1/6. Okay, so that will give you 26, and that is the average value of x. The average value of x squared will be defined as this xi squared pi. And for this example, it would be 1/6 1 plus and now we will, because we are adding the squares, plus 1 plus, which is whatever it is divided by 6. And that will be the average of x squared. If I have any function of x, then how will we do it? Well, what is a function? A function takes a number and gives you a number. This will be so this is how we define averages. There is a probability for a certain random variable, and then the average and the square of, and then the square, and then any cube, etc. All of those are then defined in this way. Obviously, average of 1 is what? 0%. Average of 1 is 1 times pi, and since this adds up to 1, the average of 1 is 1. So these are very strict, these are definitions. And now we can take advantage and do, we can see what these would mean. Now, you see over here that when I took the average, here this cancelled against this cancelled against this, and this added up over here because x6 was plus 11. Here there is no cancellation, squares. So all of these are positively weighted. 1, 49, then 49 comes in with 49. So it doubles up. So this is good. This tells us there's something very different between average of x squared and average of x squared. Let's see what exactly that relation is. Okay, I'm going to take this. I'm going to take xi and subtract from it the average value of x. ये 0 हो जाएगा. So suppose I take the average of xi minus the average of x. Well, this. Yes. Average of x minus. Okay. X minus average of x average. X minus average of x average. What is the meaning of this? You look over here. It says whatever there is, you put the I, you put I over here and pi. Okay. So this is summation I equals 1 up till n. Pi xi So let's expand this out. This is pi xi minus now this is some number, it does not depend upon I, but this is equal to 1 and this is what we call average of x. So this is equal to average of x minus average of x, which is equal to 0. So this quantity, the average of x minus x average is 0. But what about this? I take x minus x average, take the square of this. Well,
ये x minus average of x लिखा है इस साइड पे, इसके साथ I क्यों नहीं लिखा है?
किधर?
इस साइड पे, जो x I minus average of x.
इधर? देखो, यहाँ पर हमने एवरेज ऑफ एक्स को यूं डिफाइन किया कि आप तमाम आइस के ऊपर सम कर देते हैं। एक्स आई को उसकी प्रोबेबिलिटी के साथ वेट करते हैं। अगर 1 को आना है तो आप 1/6 के साथ वेट करेंगे, अगर 7 को आना है तो आप फिर भी 1/6 के साथ, तमाम के ऊपर आप सम करेंगे तब आपको ये एवरेज मिलेगा। So now let's look at this. Well, this is equal to, again, pi, and now we have xi squared, x minus okay, so this is pi. And now let's open this out. So this is xi squared minus 2xi x, and then there is a square of this. Which we can write as 3 separate terms. This is minus 2 and then what is this thing? This average of x squared. So this is average of x squared minus 2 average of x, and what is this? This is average of x also. So we have this. Now sum of all probabilities, sum over pi is 1, which means we have over here and so this is equal to x squared minus this is actually a very important result. So this is given a name called variance. And sigma is therefore, you can write it in 2 equivalent ways, x minus average of x squared, which is the same as x squared minus average of x squared. This is important to remember. Why is this important? It says, look, the average of x can be 0. But the square will not be 0. It's still possible that the average can be 0, but the square of that random variable will not be 0. There is a, let's work out a problem where the variance is not 0. This is called the drunkard's walk. बंदा निकलता है तो वो एक कदम नहीं देख रहा है, अब आगे किधर जाना है। हो सकता है आगे चला जाए, लेकिन हो सकता है कि वो पीछे चला जाए। So he will sometimes be doing this, sometimes be doing this. And here is and so the question is, how far will he move from the point where he started? निकला
लगता है कि वो आधा घंटा वॉक करने के बाद भी उतनी पड़ा
बिल्कुल हो सकता है, लेकिन हो सकता है कि आधे घंटे के बाद वो उधर पहुंचा हुआ, वो भी हो सकता है। क्योंकि रैंडम है, 50% चांस है कि वो आगे जाएगा, 50% चांस है कि वो पीछे जाएगा।
रैंडम वॉक हो गई,
इसको रैंडम वॉक। So let's work out that problem. So इस पर कोई पाबंदी तो नहीं, ऐसे प्रॉब्लम्स डिस्कस किए थे। बताना मत किसी। And this is a one-dimensional random walk. In either direction, with equal probability, with probability half. Right, 50% that he will step forward, 50% that he will step backwards. After n steps, what will be average distance from the starting point? And the next part will be after n steps, what will be the square of the average? Average of the distance what will be the average of the squared distance. From the starting point. Okay, so what is the random variable over here? Give it a name, let's call it x, right? X. So he is taking n steps. So x1, x2, up till xn. After n steps, if you had taken all the steps in the forward direction, how far would you have gone? अगर probability 1 होती आगे जाने की, तो n steps के बाद वो कितनी दूर पहुंचता? L times n times n. और अगर दूसरी तरफ जाने की प्रोबेबिलिटी 1 होती तो फिर कितनी दूर पहुंचता? वही नहीं होता, माइनस n है, क्योंकि आपको एक वो यहां से शुरू, if he keeps going in the forward direction, so if he keeps going here, then here, and then here, and then here, then after n steps, he will have reached a distance n times l. If he moves in the backward direction, he will come here, which is minus l. Okay, so the total distance that he will move will be x1 plus x2 plus xn. Now each one of these is a random variable. Let's take the average of x. So the average of x will be the average which is but average of x1, average of x2, all of these is 0 because there's equal probability to go forward or to come back. And so this is 0 plus 0 plus 0, etc. So this is equal to 0. So on the average, he will be found here, where he started from. ठीक?
सर हमने पॉसिबिलिटी की तो बात नहीं की.
क्या?
पॉसिबिलिटी की तो हमने बात ही नहीं की. 1/c जो है हमारे पास, प्रोबेबिलिटी जो है